Redox reaction. Redox reaction is actually, it is a combination of two reactions, that is called reduction and plus oxidation reaction. Reduction, oxidation, these two are half reactions, half reaction, half reactions. And in any redox reactions, there is a, these two reactions take place simultaneously. Let us see what is the meaning of these two reactions. Reduction means gain of electron and oxidation means loss of electron. So any reaction in terms of electron concept, loss of electron is equal to gain of electron. You can remember like this thing, while in oxidation is loss and reduction is gain. Second is loss of oxygen or addition of hydrogen, here loss of hydrogen or addition of oxygen. Third, you can say it takes place at cathode, it takes place at anode. So you can remember like R is red, red means reduction at cathode. Here for anode you can understand an means anode, oxygen, anode oxidation reactions. One more concept, reducing agent and oxidizing agent. So what is reducing oxidizing agent? Reducing agent is a substances that gives hydrogen or remove oxygen, and oxidizing agent are those substances that gives oxygen or remove hydrogen. Second point, it reduce other substance, it oxidize other substance. Third point, it loses electron and oxidize themselves, it gains electrons and reduce themselves. What is the actually meaning of reducing agent? Reducing agent is act as a role of traveling agent. It acts as a role of traveling agent. What is the role of traveling agent? A traveling agent book ticket for the travelers. He booked for travel, but he never tells themselves. So a reducing agent always what reduce other substance. They reduce other substance, but oxidize themselves. Similarly, oxidizing agent always oxidizes other substances, and reduce themselves. So with the help of reducing agent, we can remember what is meaning of traveling agent, what is the meaning of reducing agent. Let us see one example. Copper oxide plus hydrogen, it will give you copper plus hydrogen. You can see here, so in this oxygen, in this reactant, oxygen has been removed. So this is process called reduction reaction. Here within hydrogen, oxygen has been added. So it becomes to water. So this is called oxidation reaction. This is a reducing agent and this copper oxide is a oxidizing agent. So we can see in terms of electron concept, R reduction means copper plus 2 electron, it is giving you copper, and hydrogen here H plus. So hydrogen is converting into H plus ion, so 2 electron is given out. So we will see some other reactions, other examples. So one more example is H2O plus Cl2. Okay, it will give you sulfur plus HCl. So here again we can see oxidation, removal of hydrogen in Cl2 converted to Cl. So this is reduction, addition of hydrogen take place. So we can see in terms of electron concept, oxidation, reduction. So H2 minus is converted into sulfur plus 2 electron is balanced. So here sulfur, 2 electron this one, 2 electron this one. Cl2, if you add 2 electrons, you will get Cl minus. So electron, in terms of electrons, both are equal to each other. So this is a complete oxidation reaction. And Cl2 is acting as an oxidizing agent and H2S is acting as a reducing agent. So it gets oxidized and it gets reduced. So it is easy, reduction, oxidizing agent. Here if oxidation occurs, so it becomes oxidizing agent. Now we are moving to one more topic, types of reduction. So this is reaction is actually for comparison purpose. So it will help you in understanding the redox reaction more properly. What is intermolecular redox reaction? It takes place between two different reactants. How? Zinc and H2SO4, they are two different reactants. So it will give you zinc sulfate plus hydrogen. So what is the oxidation? So here zinc, write zinc here. Here zinc is 2 plus, sulfate is 2 minus. So zinc 2 plus, write 2 electron. In reduction, H, this H plus, so right here 2H plus, and this H2 this side, product side. So H plus you will convert to H2 only after gaining electrons. So this is reduction, this is oxidation. Take one more example, H2 plus O2 will give you water. So here oxidation is what? H2, here this is H plus, here 2H plus. So H2 will convert to H plus only after losing electron. In reduction, O2 plus 2 electron, it will convert into oxide. This is oxide, O2 negative. This is oxide, O2 negative. So it is only possible it will take 2 electron. So these two examples of intermolecular redox reactions. Next example, next type of reaction, intramolecular redox reaction. So this reaction takes place within two different atoms of same reactant. Within two different atoms of same reactant. How? AgBr, it will give you Ag plus Br2. Already we have seen this is photolactic reaction. So here reduction Ag, this is your positive cation. It will take one electron, it will convert into product. So again similarly Br, right here Br minus, here Br2. So this reaction will convert to Br2 only after losing electrons. See, it is also example of intramolecular reaction. So this is one reactant but two different atoms of same reactant. So let us see third one. Third is your disproportionation reactions or autoreductions. In this, one atom in a reactant undergo oxidation and reduction reaction simultaneously. So we take one example, 2H2O2 hydrogen peroxide. On heating it will give you 2 molecules of water and 1 oxygen. So this is decomposition reaction, but a type of auto-redox reaction. We can see here O2, if you had remove 2 hydrogen, it will remain as O2 2 negative. It will give you oxygen and 2 balanced electron, right, 2 electron this side. So this is a loss of electron. Hydrogen peroxide also give nascent oxygen. So nascent oxygen, when we take 2 electron, it will give you oxide ion, same thing. So here we can see these 2 oxygens will acting as a oxidation reduction reactions. How this nascent oxygen come, this we will learn under a concept of oxidation number in competition corner section. So we will do one more topic, competition occurs separately after finishing this CBSE portions. Other type of reactions, see here. So other type of reactions are methane plus oxygen. This is give you CO2 plus water. This is a combustion reaction. Combustion reaction takes place in presence of air. Let us take any hydrocarbon. So if you give air, if you burn in air, so what will happen? This will convert to CO2 plus water always. How to balance this type of reaction? See here. So you take CXHYO2. So it will give you X CO2 plus Y by 2 H2. How it comes X? How Y? It comes Y by 2. Here carbon is X. So to balance CO2, put here X. Again here one hydrogen is Y number of atoms. So here 2 hydrogen already there. So if you divide Y by 2, it becomes 1 hydrogen. 2 to cancel 1 hydrogen. How many oxygen left? Here 2x, Y by 2 into 1 oxygen, Y by 2. So total oxygen is 2x plus Y by 2. Put this value over here. Here we have already 2 oxygen, so divide by 2. So it will becomes x plus Y by 4. So 2 to cancel x, Y by 2 into 2 Y by 4. Put this value CXHY plus x plus Y by 2 oxygen. It will give you x CO2 plus water, Y by 2 water. So you can practice. We have different type of hydrocarbon, alkane, alkene, alkyne, CnH2n plus 2, CnH2n, CnH2n, 2n minus 2. So we can write here value and practice it. This is very easy questions for your understanding. Now we see some more other type of reactions. Na2CO3, it is a carbonate. So any carbonate, if you heat it, like calcium carbonate, if you heat it, it will convert into calcium oxide plus carbon dioxide. But this is the only exception. So if you heat it, it will not give you any product. It only get warm up, heated. Nothing will happen. Second, sodium bicarbonate. Sodium bicarbonate always give carbon dioxide plus water. Carbonate and bicarbonate both give carbon dioxide plus water. This is the decomposition reaction. Next, copper sulfate 5H2. This is called as blue vitriol. So this will give you copper sulfate and anhydrous white. So there is a color change. Plus water is also released out. So this is a type of dehydration reaction. So this is a physical phenomenon of dehydration reactions. Let us see one more thing. C2H5OH plus conc H2SO4. So if you heat it here, what will happen? It will give you C2H4. This is a ethene gas. Okay, this is ethene gas plus water. So here this water is being absorbed. Absorbed by conc H2SO4. So this conc H2SO4 is acting as a dehydrating agent. So this is an example of also dehydration reaction. This is also example of dehydration. But here the proper reaction is there. So this is a chemical phenomena. This is your physical phenomena and this is your chemical phenomena. Next, we have other dehydrating agent also, H3PO4, calcium oxide. So they will also absorb water from the reactant or atmosphere. So this depends on the situations. Now next is SiCl4 plus water. So this will give you SiOH whole 4 plus 4 plus HCl. So this is silicon hydroxide is actually hydrolysis reaction. What happens here? H2H is split into H plus and OH minus. So H plus OH minus. So when any water is splitting into H plus OH minus, so this is called hydrolysis. We have seen this reaction in double decomposition reaction with magnesium nitride. Next is sodium carbonate plus 10H2. It will give you sodium carbonate 10H2 water. So this formula is called as washing soda. This is the example of hydration reaction. So in this is what happens. Water molecules has been added to sodium carbonate and we are getting some hydrated salt. So what is actually hydrated salt? Which contains water as a crystal in any reactants. This type of compound is called as water of crystallization compound. So we will learn more in next topic. Thank you.